Our primary focus on quadratic expressions is on how to use factorization method to work out a quadratic expression. For us to begin, it is important that we explain some basic things about quadratic expressions. So the very first thing you should know is that an expression is quadratic when the highest power of your known variable is equal to 2. This means that a linear expression does not qualify as quadratic. Neither does polynomial expressions qualify as quadratic. Number two thing you should know is that for every quadratic expression, the general form is of the nature ax squared plus bx plus c. What this implies is that the coefficient of the squared of your known variable is a, while b stands at the coefficient of your known variable itself, and c is just a constant standing on its own. Now, for us to be able to factorize any given quadratic expression, something important we can bear in mind is the expression of this nature. X squared plus, open a bracket, alpha add beta, close the bracket of x, plus alpha times beta. Alpha add beta simply implies that for us to factorize a quadratic expression, we will need two factors that when added together should be able to generate the value of b. At the same time, alpha beta together means that the same factors which we added together to get the value of b, we need to multiply them together considering their signs at the same time to generate the answer c, or constant c. We are going to work out with this expression demonstrated on the board here, since our very first focus of consideration is a situation where the value of a is unity, and that is why we have not considered what is next to x. So this is a case where a is equal to 1. Take that down as we'll be working alongside that. Now, to begin with our today's class, let us demonstrate with one example to see how x squared plus open bracket alpha plus beta close the bracket x add alpha beta will help us to work out factorization of algebraic expressions. Take a look at this example. Example number 1. Let's say we are given an expression x squared add 5x minus 6, and we are asked to factorize this quadratic expression. How do you do that? How do you make it appear in this form? First of all, notice that the expression we have been given here directly stands in place of ax squared plus bx plus c. So that is to say that the expression we already have here passes or qualifies as a quadratic expression because the highest power of the known variable is 2. That's point number 1. So done. Number 2 test. Notice also that the variable x squared has a coefficient of just 1. Remember, we are looking at a case where our a is equal to 1 or unity. So this passes for what we are talking about. The next thing we need to look at is how to reach our alpha and beta added together and how to reach our alpha and beta multiplied together. So to do that, let us consider various factors that will satisfy our situation. So I'm just going to bring it down and write it as x squared add open bracket alpha add beta close the bracket x. Take note, alpha add beta can be represented with any kind of variable. Take note of that, okay? Then add alpha times beta. Most of the time in some textbooks you see it written as a plus b close the bracket x plus a times b. It is normal also. The reason why I have decided to make use of alpha and beta together is to show a difference between the factors we are looking at and the original quadratic expression given in the general form. Okay, now our very first focus is 5x. We think about two factors that we can add together to give us the number 5 positive. Now, you may think of the numbers 2 and 3. Yes, if we look at the number 2 and 3 together when added, will give us the number 5. That is true. But what if I multiply the number 2 times 3? Would it give me negative 6? No, it's not going to give me negative 6, so it's not equal to negative 6. Therefore, 2 and 3 do not qualify. Let's try other numbers. What if I try out the variable 5 and 1? Let's say 5 and 1. 5 add 1 is not going to give me the number 5, but it's going to give me the number 6, which of course is not what we're looking for, because our focus here is to look for alpha multiply beta to give us -6. So let's think of something else. The next thing we can think of this time around is 6 minus 1. Yes, this is going to work because 6 minus 1 leaves us with 5, positive 5. As you can see here, remember, addition of alpha and beta, addition of the two factors should give us the B term. Why, when multiplied together, 6 multiply 1, -1, take note, 6 multiply -1 will give us -6. So do you see, 6 and -1 are the numbers to take the place of alpha and beta. Now the next thing you should take note of here is that it doesn't matter which one is the first number. It doesn't matter if alpha takes the place of 6 or beta takes the place of -1. We can reverse it and say alpha takes the place of -1 and beta takes the place of 6. The most important thing is that we know the factors we are working with. The next thing I'm going to do right now is to substitute 6 and -1 in place of alpha and beta, as demonstrated in the expression shown above. So let us see if that is going to work out our factorization. So I just bring down my x squared plus, in bracket in place of alpha, I am going to write 6, and plus, in place of beta, I'll write -1. Close the full bracket. X is still outside. Plus, my alpha again is 6, while my beta is -1. I just place them in bracket to separate them enough. So at this level, I'm going to open up all the brackets to make them look simple. So x squared plus, open this bracket first. Let us try multiplying them with x and also try simplifying what we have inside, because plus and minus can't just stay there. You get the point. So to do that, 6 stays alone, plus and minus will give us minus, 1 stays alone, close the bracket, x plus, divs the plus, let's see, 6 times -1 will give us -6. So when we open up the bracket, this is going to be x squared plus 6 times x is 6x. Minus 1 times x is -1x. Or you can just write it as -x. Then positive times negative gives us -6. Now, since we have reached this level, we can easily apply our basic skill of factorization by grouping. In that case, I can group x squared and 6x together, while -x and -6 can also be grouped together. Now our factorization is going to work out swiftly. In case you haven't seen my video on factorization by grouping, you should try to see it so that you can understand exactly what I'm doing right here. In fact, I have made 3 videos on factorization, A, B, and C, so that a clearer understanding will be there when you see the videos. Let's go further. So x squared and 6x have a highest common factor of x, which I am directly going to factor out here. So when that is factored out, x stays outside, and then the very first thing you see inside is x, because when x multiplies x inside, you have x squared. Plus, x times 6 will give us 6x. Now for -x and -6, the only thing common here is -1. Therefore, I'll factor out -1 and open a bracket. -1 multiplies x will give us -x. To get -6, we have to multiply with +6. Because -1 times +6 will give us the -6 we have down here. Now at this level, you notice that the expressions inside the bracket are exactly the same thing. So which means they are common to both x and -1. Hence, we can factor them out as x add 6 in one bracket and open a bracket, x minus 1. When this, which you have in the bracket, when both of them are expanded further, you will notice that you only end up getting back the question from where you started. For our second example, we have x squared minus 5x minus 14. How do we factorize that? Remember the rule all the time. Remember, all it implies is you have to leave it in the form s squared add open bracket alpha add beta close the bracket x add alpha times beta. This is the basic rule. Therefore, all it implies is looking for two factors that when added together will give you the middle term, which is the b. And here our b is -5. Our b here is -5. So when we are concentrating on this bracket, we are looking at two different numbers that when added together will give us -5. At the same time, our c is the alpha times beta, which here in this expression is -14. It also implies that when we get the two numbers together here that we are going to add to give us -5, we should be sure enough that the same two numbers when multiplied together will give us -14 as given in the expression. We're going to be really fast with this so that we'll have enough time to demonstrate some others. Alright, so to do that, for -5, we can think of variable numbers that will be able to give us -5. But think of exactly the one that will give you -14 when it is multiplied together. The first thing that comes to mind is +2 and -7. When you look at +2, which is 2, and -7, when I add -7 to +2, this is exactly the same thing as when you are subtracting 7 from 2. And that is going to give you -5. We have achieved our B. But does it work for C? Let's see. The same 2, multiply it by -7. Does it give you -14? That's correct. It does. So this gives you -14. In that case, 2 and -7 will work out really fine. Now let me just show you how fast you can go working out this. Straight away, x squared, add in bracket, I have 2, -7. You can just minus 7. It's okay. -7. Close the bracket. X plus alpha times beta means -14 out there. You can keep it this way because that's what it's going to end up being. So our major focus is inside the bracket. Hence, x squared plus 2 times x is 2x, minus 7 times x is 7x, plus times minus is minus, so we have -14. Now we go into grouping. I'm going to group x squared and 2x and -7 and -14. -7s and -14. So to do that, x is the common factor we have in x squared and 2x. So I factor it out and multiply it by x, add 2, because x times x is x squared and x times 2 is 2x. Then for -7x and -14, what you see common there is -7. Hence, I factor out -7 and in bracket -7 times x will give me -7x. Why -7 times +2 will give me -14. Now you will notice here again that the two brackets have exactly the same expressions. Therefore, we pull out one of them because all it involves is being a factor, a common factor to both expressions. Therefore, x plus 2 stays alone, while x minus 7 stays alone. Now this becomes our final factorized version of the expression x squared minus 5x minus 14. The example 3 says y squared plus 25y plus 150. So what we are looking for is the b term and the c. To do that now, let's think about two numbers that when multiplied together will give us 150 positive. But the same two numbers when added together will give us 25. Now let's think about the numbers. 10 plus 15 is 25. 10 times 15 is 150. Therefore, instead of bringing out all the steps that I showed earlier in the other examples, what I can easily do is to substitute 10 and 15 in place of 25. That is going to be that 25y now changes to 10y plus 15y straight away. So our 150 comes down. At this level, you can deal with factorization by grouping. So you notice that y is common between y squared and 10y. Therefore, I factor y out. And in the bracket, y multiply y will give me y squared. And then y multiply 10 will give me 10y. The first bracket is over. For the next bracket, we have 15 and 150. The number common there is 15. So I have to factor out positive 15. Positive 15 multiplies y, give you positive 15y. And positive 15 multiplies 10 will give you positive 150. At this stage, just notice that the brackets are the same. So when the brackets are the same, it simply means that they are common. Hence, you pick one out as a way of factorization. Y plus 10 is taken out or factored out in one bracket. Y what is remaining is y plus 15. This is our final answer when y squared plus 25y plus 150 is factorized. This is how easy it is. Notice in this third example I just showed you that we did not actually take so much steps to solve it. Earlier on, I needed you to see how it works, but I believe that from example 1 till 2, and then by this third one, everything is clear enough. I'm going to show you one last example that might be a bit confusing. Let's solve it together. I will advise you to pause the video, try it first, and then unpause the video to see if you really got the answer right. Let's do it. Now, for our last example, which is of course example number 4, we are given x squared minus 2xy minus 8y squared. Our very first focus is to look for two numbers that when added together will give us -2, that's b. And at the same time, the same two numbers when multiplied together will give us -8. So what are the two numbers? Without wasting time, the numbers I can think about right now are 2 and -4. How did I know that? I know that because if I work out 2 add -4, that obviously is going to give me -2. It's the same thing as subtracting 4 from 2. And at the same time, if I work with the same number, multiplying 2 and -4, that's going to give me -8. So my C is already found and my B is also already found. Therefore, my very first focus is the middle. Instead of writing minus 2xy, this time I just have to fix in +2 and -4, taking note of the variables x, y. So let's do that. So it simply means that x squared minus 2xy, which is given our problem, minus 8y squared will now change. It will now become x squared plus 2xy minus 4xy minus 8y squared. Now at this level, you just have to do factorization by grouping. In x squared plus 2xy, what is common is x. I factor it out and open my bracket. X into x gives me x squared plus x into 2y will give me 2xy. The left hand side is done. For the next bracket, I have -4xy and -8y squared. First, -4 is already common. At the same time, y is also common. So I have -4y as the common factor, which stays outside. So for the inside bracket, -4y multiplies x will give me -4xy. To get the -8, I have to multiply it by +2. But remember the y, +2y, because 4y times 2y will give you 8y squared. The negative sign is already there waiting for you. So if you take a look at the level we have reached so far, you would notice that x plus 2y appears in both brackets. This implies that x plus 2y is common to both x and -4y. For that to happen swiftly and smoothly as well, I will have to factor it out this way. X plus 2y is thereby factored out, while x minus 4y will also be in the next bracket. Now this is it. We have ended up factorizing the expression x squared minus 2xy minus 8y squared. The beauty of this kind of expression is that you can tell the answer straight away from the question, from that very first moment whereby you discover the factors you need to work. All you need to do is open a bracket and fix the factors in the two different brackets. That's how it works. That's how factorizing a quadratic expression that has a as 1 works. It's as easy as that. I want to believe that you have enjoyed yourself solving today's problems, and I believe you have understood it clearly. We are going to look at factorizing a quadratic expression when a is not 1. So this time around, a should be greater than 1 or less than 1, but not 1. How would you do that? Will this work for you? Will x squared plus alpha plus beta, close the bracket, x plus alpha times beta work for you? We'll try it out and see how that goes. By the way, thank you for watching.